This is what you are actually doing, correct? Everybody knows that, yes? And yet, if I had asked each one of you why this is the case, at least a couple of you would have said, because 3 plus 2 is 5.
Because we already know that math, we're going to assume it's 3. So.
Yes, exactly. There would have been people in the room that would have said 3 because 3 plus 2 is 5. Which then leads me to this question. X plus 1.7 equals 7.2. What's the answer? Right. You would subtract the 1.7. You would subtract the 1.7. And x would equal 5.5. Right? Mm-hmm. Now, a concern I have with you people, not this class in particular, but teenagers in general, is all of you have no problem with that. But when I change the looks of it to this, a bunch of people go, ooh. No, perhaps you don't. But a bunch of people do. And you have been known to go, whoa, when I give you 2 questions in a row that are exactly the same with slightly different numbers, aren't you? So you fit into this category, which is why we are doing this right now. Okay. So then, what is this one? Everybody says 9. Why? I don't care that you know the answer. Right. What? No, 2 divided by 18 is 0.111111111. Do you mean 18 divided by 2? Yes. Why did you divide? Because this is multiply and you want to reverse it. So x equals 9. Surface area is algebra, Austin. It's a bunch of letters and numbers. You put in the letters and numbers you need, and then you do the math with it. Oh, letters, numbers, math. I know. I used to have a beard. It made that much better. But I don't now. And then, of course, x over 3 equals 9. You multiply. It's 27. Why? You multiply by 3 to get rid of the 3. That gets you x by itself. Then you do the same thing over here, and x is 27. You could cross multiply if you wanted. That's the next move. You could do that. 1x is 27. Everybody can do one step, yes?
Yes.
Excellent. Dan. There. 15 minus 5. Not minus 15, you doofus. Minus 5 minus 5. 2x equals 10. Then what? Austin. Divide by 2. And x equals 5. Yeah? Yeah. Okay. 3 halves x equals now all the wise bums are like, what would you do first, Zach? Because there's a couple of things you could do here. You would switch the 3 and the 2 over to the other side? Okay, Moret. You could go divided by 3 halves and divided by 3 halves. But that, of course, makes North American kids cry like babies because that's dividing by a fraction. And fractions hurt their brains. But it would work. Who has another idea? Dan. Right. You could do times 2 to cancel that. Then you have what? 3x equals 12. And then what? Divide by 3.
So the fraction is the constant?
The fraction is a coefficient.
Coefficient.
That's the next thing we're going to get into is the words for all these things. Once I'm happy that everybody can do it, I will start using the real words for these things. Jeremy.
Another way to do it would be convert the fraction to a decimal. 1.5x equals 6 would mean we need 1.5 equals 6.
Bring it home.
1.5 times 4 is x.
6 divided by 1.5 is 4.
Ow.
Right?
Sorry.
No, it's okay. All right. Is everybody cool? Now, Jeremy's plan works really well for 3 over 2. Why? Because it makes a nice, pretty fraction, right?
Yeah.
What if it was, just wait, what if I gave you 4/7 x equals 8? Equals 8. Hush up your faces. Could you do your decimal thing in your head, Jeremy?
Not in my head.
No, because of 4/7, right? And if we go to 4/7, what happens? 4 divided by 7. Does anybody want to deal with that? No. So, yeah. So, if you can do the decimal thing, why wouldn't you do the decimal thing? But if the decimal thing is then you should go to this way, right? So what would you do to sort this guy out? Multiply each side by 7. I know, it drives me up the wall too. It's okay, it's not your fault, right? But that's not the words. So what happens to these 7s? Gone. 4x equals what? 56. And then what? And what does x equal? 14. Everybody cool? Now, what if this isn't a perfect number, like up here? It had a decimal. Does that matter? No, of course not. It's still the same math. Is everybody cool with all of these 2-step jobbies? Yes?
Yes.
Really and for true?
Yes.
Relax, sister. Whew. Okay. 2x plus 5 equals 3x plus 8. Oh, no. Whatever will we do?
Put the variables together. And you
Put the variables together? Okay.
2x,
3x. They're together.
Wait, just look.
Combine them. Oh, okay. So 3x. They're combined. No? Okay. Dan. Pardon me? 5x plus 13. What are you doing to get 5x? You've been did. Dan. Actually, this was not fair of me. This is 2 steps away from where I wanted to go. I'm going to, put a pin in that one, and let's change it to this one. You've been dudded. 2x plus 8 plus 3x plus 2 equals 20. Now, let's do this one first. I have a reason. Yes, go ahead.
You put the 8 and the 2 on the other side of the equal sign, and then you put...
Okay, so I'm going to put the 8 and the 2 there.
You gotta change them to negatives.
I got to change them to negatives?
Yeah.
Why?
Both positives. And on the other side, yes. It's
Okay.
like going across this border.
No, again, the answer is why.
Because
Why am I doing that? Jeremy.
You bring forget what the term is.
Don't worry about math words. We'll build them up.
You take matching terms or whatever
Yeah,
to
they're
the
like
side
terms.
with other matching terms.
Excellent.
they're like
But
terms.
when it crosses the equals line, it has to reverse. So a multiply would become a divide.
Okay.
And a addition would become a subtract, and vice versa.
Okay. Why? Everybody knows what to do.
Because the equal
I want to know why you do it. Dan.
So like when you put a long thing, so if you try to make a similar like shoulder,
Yep.
it's easy to do the math without getting.
Yep. Okay. Okay. But the question I've asked is why do we need to change the signs?
because then it would be a big number. I don't know. Actually,
Yeah, see? So we got the right answer. Aaron?
So it's even?
Thank you. So it's even. What does this symbol right here mean? Equal. Right? That highlighted symbol means everything on the left side is equal to everything on the right side. Yes? Means they're exactly the same, right? But all of you know that you have to isolate your letter, yes? At the end of algebra, you have a letter isolated, right? So if I'm going to isolate this x, I can't have any numbers with it, correct? So I have to get rid of that number and that number. How do I get rid of 8?
you put it to the other side.
I take it away. If I take away 8 things from this side, what must I do over here? Take away 8. So what is actually happening is minus 8, and minus 2, minus 2.
And they're like terms.
The shortcut that you guys have been taught is you bring them over and switch the sign, which is wonderful until you forget. And it's real easy for a math question to make you forget that. So know why. Now, do I have to do minus 8 minus 2? Or could I do this? 5x plus 10 equals 20. Is that okay, Gervir? Why? Because it's the same thing. I got 2 x's there. I got 3 more x's there. Last I checked, 2 and 3 was 5. Right? Excellent. And the last I checked, 8 and 2 was 10. No. For adding? Really? This is not elementary school anymore. You do not get a gold star for doing something that I can teach a monkey to do.
Do monkeys understand English?
Mm-hmm. There's monkeys in the world that understand like 500 sign language things, just like in the new Planet of the Apes. All right, Caesar. That speaks, and then he learns to talk with the voice box that apes have. They don't. No, he didn't. All right, so minus 10 or minus 8 minus 2. Or minus 10 minus 10. 5x equals what? 10. What does x equal? 2. All of you say you can do this. All of you. And yet, when I gave you this,
Sorry for this interruption. Teacher, Rouse grind that already aren't in the character center? Can you head down, please? Because that's what's about to be.
Go grinding. Grind on.
Roast grind?
Mm-hmm.
What's that for?
It's a hike.
Phys ed. Okay. When I gave you this, the bulk of you were like, you actually made that. Well, I heard you making that sound. You just went like this. But what I hear was, like when you see a movie or a TV show and the kid sees something that it really surprises them and they pull the camera way out and the kid just sits there, but there's music in the background that's going, you know that move? That's what you did when I gave you this. How is that, with an S there, any different than that? It isn't. It's exactly the same thing, isn't it? It has pi in it.
No, because like you have to find the radius and the slant.
How is it any different? So wait. So now 2s plus 8 plus 3s plus 2 equals 20. You're telling me that if I ask you to find s, you can't do it?
No, because
That's what you just said.
I just said
Those are the exact words you said. I have to find slant, so I can't do it. How is it different? Pi r squared. Pi times r squared. Times. What do you do to get rid of a times? See, I said times for you. What do I do to get rid of multiplication? You divide, just like over here, right? What's the difference? That says pi. Isn't pi just a number? 3.14159, blah, 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 blah. It's still a number, isn't it? So if I gave you 5r squared equaled 125,
so
you could solve it.
5 times whatever the radius is.
Yeah, you would divide by 5. You would divide by 5. R squared equaled 25. Then you would square root. Right? If I put a 5 there, no problem. I put a pi there, all of a sudden you can't do it anymore? Because I know the rules in math change, right, guys? Math is different every single day you come and do any math, right? Yesterday, 5 plus 2 was 7, but today, who the hell knows? It could be 29. Is it? No. Why? Because math doesn't change. So now, let's go back to that one everybody was fighting to do before. It doesn't matter. Because, why doesn't it matter, Hannah?
Because it's the same.
Because math is always the same. Whether Albert Einstein is teaching it to you, the greatest math mind ever, or your kindergarten teacher who taught you 3 apples and 4 apples make 7 apples. Here's your gold star, even though I did all the work for you. Right? Right. Tabi. Pardon me? You would like me to change the 3 to a 5? Why would you like that, Tabby? Because you already wrote it. How about we remember that it doesn't matter what the number is, the math stays. So because I remember that, I'll change it. Oh, the 3. Right. I know. Shh, Marette, stop giving me away. The whole point of this, Marette, is to say that it doesn't matter what it looks like. The answers are all easy to get because algebra tells you what to do. And yet, if I put a pi in there, all of a sudden, algebra is taking you out back and showing you what it's like. That's not what is happening.
Equation. Is it okay if I answer the equation?
Mm-hmm.
Okay, you take the 5 away from both sides. You've got
Okay, minus 5.
2x.
What's 3x take away 5? I can't do it there, can I? But that's what Jeremy told me to do. He just take away from the other side.
Take the 3x away from both sides.
Take the 3x away from both sides. Okay.
No, take the 3x away from the 2x and from the
There we go. Okay, now we're talking because we're.
Gives us negative x.
That's cool. I'll come to you in a second, Gervir.
Take the 5 away from the 5 and the 8. That gives us 3. Negative x equals 3. Therefore, if we swap it to make it so x is positive, we've got x equals negative 3.
Of course, you would divide by -1.
Oh.
And x is -3. Now, Gervir says he would do it the other way. What's the other way, Gervir? So, 2x plus 5 equals 3x plus 8 minus 2x minus 2x minus 8 minus 8. -3 equals x.
X equals -3.
Well, aren't these the exact same thing? So when something looks different, it can mean the same thing, right?
Yeah.
Kind of like when 5r squared is the same as pi r squared, right?
Leave me alone. Stop.
I will not leave you alone because all of you keep telling me that if you change the way math looks, all of a sudden you can't do it,
That is true.
which is horse pucky.
A horse hucky? What?
Horse pucky. It's the safe word for horse feces. Yes. All right.
Can't say
So.
the actual word. Keep losing.
Okay.
No, we get demonetized on YouTube if
2/9 x plus 5 equals 90.
You times each side by 9 and then...
You would multiply both sides by 9
subtract
first.
The 5 with the 90.
Of course you would subtract the
Because
5
you
from the
guys do
90.
No, constant.
Your goal is to end up at the x, yes?
Yeah.
So you should start where? At the x or away from the x?
Away from the x.
Right. If we were driving to Disneyland, do we start driving in Disneyland?
No.
No, we'd start far away from Disneyland and drive to Disneyland, right?
Yeah.
And if you're smart, you stop at Crater Lake in
have no
Oregon on the
choice,
way
though.
because Oregon is awesome and Crater Lake is gorgeous. And don't listen to the flyer when they say it's a strenuous hike down to Crater Lake. It's a strenuous hike for Americans. It's not a strenuous hike for us.
What did we want in California or Florida?
Oh, California. Florida is all blah, blah, blah. California's OG Disneyland.
I only went to Universal Studios.
All right, so -5 minus 5. 2/9x equals what?
It's a nice 7.
Except it's not a 7 because the 7 would have had a cross down there.
Well, that's how you draw 7s.
I know. So you always know they're a 7. If there's no cross down there, it's not a 7.
Okay.
Now what?
Now you times each side by 9.
Multiply each side by 9.
And times again.
I know you did. Can you do that in your head?
No.
You should be able to because it's 850, 85 times 10 minus 85. So it's 700 and...
765.
Okay.
What?
You're right. 2x equals 765. Now what?
Divide each side by 2.
X equals
382.5.
382.5. Yes? Now, all of you are the members of the cadre of grade 10s who told me that you have trouble with this. Why? If you have no trouble with this, why are you having trouble with 100 equals pi 5 squared plus 5, plus pi 5s. Let's change the s because s looks like 5. Actually, let's change the 5 so it doesn't look like s. 7 squared plus pi times 7 times s. Tell me, you have to tell me because I do not understand why all of you can do that, but if I go to here, all of a sudden you can't.
Which one is the constant?
Ethan. What haven't you learned? But you have learned what pi is. Pi is just a number. This is the exact same as saying 5 times 7 squared.
We don't know what
How would you get rid of that 5? You would divide, right? Okay, and you would divide both sides by that 5, wouldn't you? So ask me or tell me how putting this here, because is that 5? It is? Everybody hold up 5 fingers. This looks like 5 to me. That doesn't look like 5. What is that?
it's a 5.
No, it is not. No, it is not. Don't be a wise ass.
Number.
It's a number. Is it 5 things? No, what is it? It is one thing that represents what? 5 things. Everybody understand? Okay. So this, Ethan, is just a symbol that represents this many things, correct? Okay, so what is that? That's a symbol that represents what?
Numbers.
3.14159. It's
Okay,
just
but-
a symbol.
Tell me.
That's the exact same thing as a 5 or a 7 or a 12, right?
Tell me, how would we know which is the coefficient and the constant?
The coefficient is anything that multiplies anything else. So, 2,
So they're both
3,
coefficients?
no. 2 is the coefficient because it multiplies the 3.
No, but like the pi and 7 squared, and then the pi and 7 squared.
Okay,
multiply.
what is 7 squared? 49. Right. So this is 49 times pi, yes?
Yeah.
Which is the exact same thing as 49 times 5. 49 times 5 is 145. I mean, 245. Right?
Yeah.
Okay. So how did you know that? You did 49 times 5. Well, this is 49 times pi. Right? No, I'm doing that for you. This is 49 multiplied by pi, yes?
Yes.
So to get rid of this 5, you would divide by 5, correct?
Yeah.
So to get rid of this pi, you would divide by pi.
Yeah.
So what is different?
Okay, then go back.
If
to
I walked in here wearing boxer shorts pulled up to here, my jeans pulled down to my knees, and a bandana and a tank top, a white tank top,
with grease on it.
yeah, and then taught you math, would you still be learning math? Yes, but I would look different, yes?
Yeah.
Would you still be learning math?
Yes.
Okay, math looks different. Is there any reason to not be able to do it? No. How do you know if you can do something? You try it, right? If I went out on the football field and painted the field blue,
Would you still be able to?
could you play football?
Yeah.
Of course you could. Right? Of course you could.
As long as you didn't
I know.
paint them with the lines, they could. They can't do it without those lines.
Okay. Go
All
back
right.
to those questions
So,
that we were doing.
well, this is that question we were doing.
Oh, really?
Yes, except I changed the 5 to 7, and I changed the 100 from 1,200.
Figure out how it's wrote out.
That's how it's... Oh, really?
Like, go back to the thing.
Well, wait. The question said that you had a cone with a surface area of blah.
1200, I think.
It was 1,200 and a radius of 5. Find the S. So what's hard? Do you have to memorize the formula of a surface area?
How would we know when to put in the 1200?
Did you have to memorize the formula of a surface area? Did I ever ask you to memorize it? No. What did I give you?
The sheets.
I gave you a sheet. SA equals pi r squared plus pi r slant. Yes? And then in the question, I told you surface, I forgot the R, surface, I'm going to forget the R again just to keep it, surface area, surface area, in the question I said was 1,200, yes? If the surface area is 1,200, what does SA stand for?
1200.
Surface area is 1,200.
Okay, so
So wait, let's see if you can actually do this. Ready?
Yeah.
Your teacher is named Matt Myers. I am your teacher. Therefore, what is my name? So you can substitute. Right? The surface area is 1,200. SA is the surface area. So what is the surface area? 1,200. The radius is 5. R is the radius. So what number do you put for R?
5.
What if the radius was 3.78?
Then you put 3.78.
For surface area or for R?
R.
R. So where's the complexity?
Okay. Let's see how to do this. How did you write it up though? Because you added the 1,200
I
after you
did it like this. And then I simplified. 100 equaled 49 pi plus 7s pi. Right? Now 49 pi is just a number. Right? And since it's positive, that's a positive number, isn't it?
Yeah.
So if that said 22, you would do minus 22, wouldn't you? To get rid of it? If I had this, 3 equals 22 plus 2x, you would do minus 22 there, wouldn't you? So why here would you not do minus 49 pi? Right?
And would you do the same thing
Now,
for 100?
of course you would, because the rules never change. If you change this side, you have to change this side. So I have 100 minus 49 pi.
Why is that you 1,200 though? If that's
It doesn't, because it's a different question.
Okay.
Because the numbers don't matter.
Right.
The method matters.
Okay.
Equals 7s pi, right? Now, if I told you that you had 28 equaled 7s, what would you do with the 7? 30 of you, what would you do with the 7? You would divide to get rid of the 7 because you're down to the last step, correct? So how would I get rid of this 7? I would divide by that 7, correct? But there's also a pi. How do I get rid of it?
do whatever number is times.
You would divide by pi. Now the 7 is gone and the pi is gone. That's algebra. You can all do
So 100
that. So you can all do
4.5472.
that. Now the problem is, a great many of you, when you have to give me a number there, don't know how to punch that into your calculator. But do I care about that? If you can get to there, isn't that the hard part? Yes, because if I give you enough practice, you can learn to punch anything into your calculator. But your calculator will not get you to here, will it? You have to get to here. Do you all understand me? Everybody? So, let's go. I'm going to go get you guys some of those little jokey puzzle sheety things
Yay.
that are algebra.
Okay.
Now listen to me. I know that some of you, about halfway through those jokey puzzle sheets, you start to see what the words are going to be. And you start cheating, right?
Yeah.
You know you do, right? Right? If, for example, what did the Californian say when he jumped in the bathtub? He said Eureka. Because there's a town in California called Eureka, and the Eureka word is from Archimedes jumping in the bathtub and making it go up. Regardless, let's say you solved EU blank E blank K A. You would know that that was an R and an E, and you would cheat, and you would just put the R and the E in there without doing the work. Right? You can be honest, because that's what I did when I was your age. But when I did do that cheaty move, it was after I had done so much algebra that I could do algebra. Understand? Everybody picking up what I'm putting down? Okay. I'm going to go get you those sheets. 2 of them are just algebra. 3x plus 8 equals 27. Whatever, right? Two of them are that. But one of them is the reverse of that. And remember how often do I say the word y?
A lot.
All the time. One of the sheets is this. A number multiplied
Oh, it's a word algebra question.
by 6
Number plus
added to 3.
So that'd be 6x plus 3.
6x. Wait, I should have said and then added to 3. 6x plus 3, yes?
Yeah.
Now, what if I take out the and then? And I move this, a number added to 3 multiplied by 6. How's that different? X plus 3. What is times 6? Just the 3? A number added to 3. Fine. And then brackets. Where? Around the x and the 3. And then what? 6. One page is that. Because that is the y of algebra. Everybody cool? Okay. I'm going to go get those sheets. They're all the way down on the first floor because the second floor photocopier doesn't staple anymore.
And then we're going to make a big mess of it.
Then you're going to work on it. Now, while I'm gone, you're going to talk about how I'm mean and how this is so easy and why are we even going over it? And then I'll come back and I'll say pi r squared plus pi r slant equals SA. And you'll all be like, ugh. Right? So I'm not mean because this is ugh, even though this is 2x plus 3 equals 10. They're the exact same thing. Exact same thing. Okay? Not being able to do this is like saying, well, I can walk, but I can't run. It's exactly what it is.
Some people can't actually run.
Everybody can run.
They're
Hey,
disability.
whether you are old or not,
You can still
if
run.
there is a grizzly bear behind you, you figure out a way to run. Now, Ariana, what if they're paralyzed or something? Then they wheel faster. That's running. What? You can still run. I know this because I play baseball with a guy who weighs 400 pounds. He still gets to first.
That's
It's not pretty.
okay.
It's not pretty to look at, but he gets to first. Then we get him a runner. Oh, yeah.